Alright, we are going to finish lesson 5.1, and this is going to allow us to have a day, hopefully Wednesday, where we can have test corrections wrapped up. So we're gonna do this through the video. So I'm gonna pick up where we left off, and so we have a curve, and it's a function, and v of t is equal to t squared. So what we've done is we've looked at this idea of let's find an estimate for the space below that curve in the x-axis. And so we've done that. We looked at ways that we could estimate it, and we're going to use a rectangular approximation method using an idea presented by a gentleman by the name of Riemann. So what we talked about is there's three ways that we can create rectangles. And rectangles have a height and they have a width. So we can use RRAM, we can use LRAM, or we can use MRAM. So we've done that. We've accumulated the space. We chose in class to go with the left parameter. And so now what we want to do is we want to talk about just what does that mean. So first semester we looked at when we do an average rate of change, what does that mean, and then bridging the gap to doing it instantaneously. So what I'm going to do is I'm just going to draw that orange rectangle, and so it's one of them in the span of our interval. And so what we did is we added up a bunch of them. But what we did is we used the left parameter to determine the height of that rectangle, and then we had the base. And in class we said that we had a base of 1/2. So with velocity, the velocity values are on the y-axis, and on our x-axis we would have t. So they don't tell us the unit, so let's use something that might make sense. So for time, we're going to use hours, and for velocity, we'll use miles per hour. So going back to that rectangle, accumulating the space, I need to know the base and the height. So my base, and let's just say that we went from 2 to 2.5 for my interval to give us a base of 1/2. So that 1/2 is going to represent the change from 2 hours to 2.5 hours. So the area of the rectangle is going to be the base times the height, the base being 1/2 hour. And now what I'm going to do is multiply that by the height. And so to get the height, I'm going to use the left parameter. The function will tell me how high up to go at 2, and I get 4 miles per hour. So half of 4 obviously is 2, but if I take hours times miles per hour, I get miles. So what this means is that from 2 to 2.5 hours, this object has moved 2 miles. So if velocity is the graph and you're trying to find the area under the curve, this is going to give us an important piece of information about the object, and it's going to give us the displacement. So on the interval from 2 to 2.5 hours, the object's position has changed by 2 miles. And because the velocity is positive, we know it's going to the right. So we would say from 2 to 2.5 hours, the object has moved a total of 2 miles to the right. So when we accumulate the total space, let me use a different color, all this space is going to give me the total displacement of the object on the interval from here to there. And often what they'll do on the AP exam is they'll say, explain the meaning of that accumulation. That's what we would do. We would discuss the starting value, the ending value, and what this means. And they like to do that in the scope of an object that's moving. All right, my notes up here got kind of mixed around, but I'd like to discuss these talking points up at the top. So let's say that we have a velocity function that looks like this blue curve that's drawn in there. And we've got a certain time interval. So again, we like t on my horizontal axis, v of t on the vertical axis. So if I accumulate the space, in this region, the velocity is greater than 0. So because the velocity is greater than 0, it's positive. We know that the object is moving right or up, one of those two directions. So that orange space is going to give me the total distance. It's going to give me the displacement in the object. Wherever it started at t is equal to 0, this is going to tell me just how far it went to the right. Now, in that next zone, I notice right here that the velocity is less than 0. So that means that it's going left or it's going down. So if I accumulate that space between the curve and the x-axis, that's how far it went left or down. So it's kind of hard for me to know what those regions are, but I could use geometry. I wouldn't use rectangles. I would use what I know about circles and what I know about triangles. But adding those together, because it went to the right and then it went to the left, whichever one is bigger would give me the displacement. So let's say that this region right here had an area of 2 units, and this one right here had an area of 1.5 units, that if I accumulated the total space from here to here, I know that it went to the right and then it went 1.5 left, so its displacement would be 1/2 unit to the right of where it started. Now, if I want to know the total distance that the object traveled, I don't care which direction it went in. I know that it went 2 units this way, and I know that it went 1.5 units this way. So in terms of how far the object was traveling, it traveled for a total of 3.5 units. So that third bullet point right here, that if your velocity is both positive and negative on an interval, and we want to know the total distance traveled, we don't care which direction it moved. It went 2 units in one direction, it went 1.5 units in another direction, for a total distance traveled at 3.5 units. So one way to just kind of work with that is just take the absolute value of velocity, graph that, and that would move this up here by taking the absolute value, and that would give you, by adding the 2, and this would now be a positive 1.5. Adding those together, I would still get a total distance traveled of 3.5. So these 3 bullet points up here, those 3 are really, really important, that when we accumulate a rate function, it gives me a quantity of something. When it is a velocity function, it's going to give us the displacement. If I do the accumulation of the absolute value of the rate function, that's going to give me the total distance that the object travels. All right, what I'd like to do is practice another type of rectangular approximation. This time we're going to do MRAM. Now, to make this a little bit quicker, I'm going to change the number of divisions. So the first thing we need to know is where. And so we said in class, let's go from 0 to 3. And then 2, we had to know how many divisions. That's n. So what I'm going to do this time is I'm going to break it up into 3 rectangles. We did 6 in class, but this time I'm going to do 3 just to make it a little easier. And that's really all I need to know is my interval and how many divisions. So that's really all I need to know is what method, what interval, and how many divisions. So going from 0 to 3, I'm going to break it up like we did before in class. From 0 to 1 this time, from 1 to 2, and from 2 to 3. So I went from 0 to 3, and 3 divisions would give me 3 pieces. And so I'm doing MRAM. So looking at each one of these zones, 0 to 1, 1 to 2, and 2 to 3. So I'm going to be building rectangles. So there's my base for each one of those rectangles. And what I need to know is what the height is going to be. So the middle will determine how far I go up. So let's draw that in there. So I'm going to go up in the middle. I'm going to go up in the middle. I'm going to go up in the middle. So that would create the height of the rectangles in each one of those zones. So I am going to figure out what the area of each one would be. So each base is 1, and then I just need to know the height. So the middle between 0 and 1 is a half. The function will tell me how far to go up, so I'm going to take a half, and the function says square the input. From 1 to 2, the middle would be 3 halves. To know how high up to go at 3 halves, I'll square it because that's the function. And likewise, between 2 and 3 would be 5 halves, and I'll square that. So a smart way to communicate to your AP reader is to show them, yep, I'm getting 3 rectangles, but now I'm going to just add them up. So being that each base is 1, all I'm going to do is really square the function that will give me. So 1/2 squared is 1/4 plus 9/4 plus 25/4. And that would be my approximation. So approximately that space between the curve and the x-axis would be found by adding those 3 values together. So do you have to simplify that? Nope. On a multiple choice question you would, but on a constructive response, well, it would be easy enough to say that that is 35/4. That writing your answer just like this means the same thing as my answer. So answer does not have to be simplified. It just has to be communicated what that accumulation would be. So again, this would be the displacement in the object from 0 to 3 seconds. So this would be in a unit like feet or miles, centimeters. We would need to be given more information for that. Just one last thing. If they had chose for you to do RAM, then these values right here would change because I'm now using the right parameter. So I would be using the value of the function at 1, the value of the function at 2, the value of the function at 3, and I'd square that. I would get a different approximation. So for this part right here, on your notes, I want you to do this. Might take you a few minutes to do it, but this is an important question that they often ask on the AP exam. So we're going to be looking for some generalizations that we can make about approximations based on the behavior of the function. So do that, and we will discuss that part in class. All right, so we're going to do the Jeep problem now. And so Mr. Super has this lovely Jeep, and it's a glorified ghetto cruiser, but it's a Jeep, you know, so it's all good. So the interesting thing about my Jeep is that the odometer, what keeps track of my mileage, doesn't work, but yet my speedometer does work. So, so what I do is I take and I record data, and that's from 0 to 120, and this is in seconds. And I'm recording my velocity, and my velocity is allowing me to record that in feet per second. So as we've been discussing, that if I look at the data and I accumulate, I notice that my velocity is greater than 0. So I'm going to accumulate the space between the velocity curve and the x-axis, and I know that that accumulation is going to give me the displacement of the object. So we're going to practice finding an accumulation where I don't know the function, but I know the data. And this is something that will be on every single AP exam. That they'll give us data, and they'll want us to do a Riemann sum. And so what I need to know is how many divisions do they want? So that's n is the number of divisions. And the other thing I need to know is what technique do they want me to use. So for this one, I want to use MRAM. Okay, so in this case, I'm going to break it up into 6 divisions. So going from 0 to 120, I've got to break it up into 6 chunks. So each chunk is going to end up being 20 units. So there's one piece, and then here's another piece, and here's the next piece, and I'm just going to keep going to make sure that I've got 6 chunks. And there they are. So in my first zone, which is right here, this is my first zone. Here we go, right there. I'm going to break it up. I'm going to label each interval. So I'm going to go from 0 to 20. I'm going to go from 20 to 40, and so on. So there's my 6 zones. So I noticed that each zone has a width of 20, so that means that each rectangle is going to have a span of 20. So I'll record that in there. And I'm going to multiply that by the height. So the nice thing about this is I don't need to really do any computation and know the height, because the data values are presented to me. So there's no function. So again, this is what they like to do on the AP exam, and this makes it a bit easier. So when I go to determine my height, it's not going to be the left bound, it's not going to be the right bound, it's going to be the middle. So right there, 10 is in the middle. So that's going to establish the value of the function, which is 44. So I'm just going to go through and mark the middle for each zone. And I'll put those values to the right here. So we have 35, we have 44, we have 15, 35, and 30. So now that I've got my rectangles established, what I need to communicate is that I'm adding all of them up. So again, these are my values right here that I have to accumulate. I'm taking seconds times feet per second. So let me write that in there. Seconds times feet per second. So when I multiply those two together, I'm going to get feet, which makes sense because displacement is going to give me the distance that I've traveled in a certain direction, and how that's different from where I started. So to do this, and again, on the AP exam, you may or may not have a calculator, so I'm just going to condense all this. So my summation is going to equal 20. All of these rectangles have a span of 20, and I'm taking 44 plus 35 plus 44 plus 15 plus 35 plus 30, and that would be in feet. So what this would do, usually this is a 3-point problem, and so I've communicated what each of the rectangle's dimensions are. I've shown what the total sum is down here, and I've included a unit. So if they have me explain the meaning of it, I would have to explain the time from t is equal to 0 seconds to t is equal to 120 seconds. The total displacement of the Jeep would be this expression right down here in feet. So being able to communicate things verbally is important on the AP exam. So what I'm going to have you guys do is, to finish up your notes, is I would like you to do the same problem, do an LRAM with 6 divisions, doing RRAM with 6 divisions, and then I would like to know, is MRAM the average of those two values? I'd like to know that. So a few things that you have to finish in the notes. Please come to class with everything being done. If you want to start the homework on rectangular approximations, Riemann sums, go ahead and do that. But the most important thing that you do is that you finish the notes, come to class prepared to discuss that, and study for that midterm coming up. Okay? So in terms of the homework, we will be working on that. Just I'm going to leave that at your discretion if you want to start that now or work on that at another time in the near future. So we'll talk soon and look forward to seeing you tomorrow.